All right. Again, the name of the topic today is sequences. Thank you all for coming. Let's begin. All right. In the board, I have several sequences. I have 1, 2, 3, 4, 5, 6, and 7 sequences. Let's begin by discussing what is a sequence. All right. In mathematics, a sequence is an array of numbers, like this one. In this sequence, you can see there is one number after the other, and that is a sequence, an array of numbers. One number followed by another, followed by another, followed by another. Sequences can be finite or infinite, meaning sequences can have a limited amount of numbers. So just, for example, this one, if I erase these 3 points, this sequence only has 4 numbers. That is possible. That is a 4-number sequence. That is okay. But in some cases, we have infinite sequences. The ones in the board are all infinite. How do you know those are infinite? Because each and every one of these has those 3 points. Those 3 points means that the organization of the numbers continues to infinity. All right? Again, hopefully you guys are writing this down. We have sequences so far. We have what is a sequence, and we have the types of sequences. We have finite sequences and infinite sequences. All right? Cool. So let's try to work with these sequences. I want you guys to go ahead and give it a try. Tell me what would be the next number that I will put in here. The next number for this sequence. Now, to know the next number, I have to recognize if there is an organization for the first 4. If there is an organization, then we can think about it and we can deduce the next number. In the chat, please, if you know the following number, go ahead and write it down. Okay, I have one person saying one number. All right, a lot of people then. Okay, cool. Okay, so you guys are saying this next number, let me write it in a different color. The next number will be 23. All right, let's see about that. Let's see, why did you guys think it was 23? Now, I'm thinking that what you guys did was seeing if there is some sort of connection between the 3 and the 8, and the 8 and the 13, and the 13 and the 18, right? I figured that is what you guys are doing, right? And if you guys are doing that, then you guys recognize that from 3 to 8, you guys added 5, right? Plus 5. And then you added 5 again, plus 5. And then plus 5. Meaning the next one will have to also be a plus 5. And you guys will be correct. This will be the next number in the sequence. Beautiful. Can we do the next one? Absolutely, just add another 5, right? So this will be 28. That is the idea behind sequences. An organization of numbers that have some sort of connection between them. A characteristic, an organization. All right? That is a sequence, guys. Beautiful. How about this one? Can we do it in this one? Can you guys deduce what would be the next number in this sequence? I have just 2 answers, 3 answers. Nobody else? Give it a try. I mean, if it is wrong, then I don't write it in the board, and that's it. Okay, I have 4, 5, 6 answers. All right, let's work with those. Some people are saying the next number will be the number 17. Let's see about that. Let's see. What would be the organization here? I'm thinking maybe you guys try to do the same. So from 2, the second digit, the second number is the 3, right? So that means I added a 1. But if I add a 1 here, the next number would be 4, right? But it is not. In fact, I have to add 2. But if I add 2 from the 5, the next number will be a 7, right? But it isn't. In fact, I have to add 3 to get the next number, right? And now, hopefully, you guys are seeing the organization. +1, +2, +3. Could it be? plus 4 means I get a 12. And that is correct. So all I have to do to get the next number is add a 5 and 17. For the people who said 17 in the chat, you guys are correct. Beautiful, guys. Again, this is the whole idea behind sequences. Nothing extremely hard. Something new. I'm assuming this is new for you. I'm assuming you didn't really study this in any other subject. So I'm assuming this is new for you. But it isn't hard, right? We are finding numbers in an organization where we didn't know what was coming. And I didn't teach you this. I didn't teach you this. You deduce it. Huh? All right. Give me a second, please. Somebody's writing things here. Okay. Give me just a second, guys. Majo Gutierrez is having difficulties with the class. All right, sorry, guys. Sorry about that. Thank you. All right, again. Let's continue with the hardest. The hardest of all the sequences. This one in here. What is the following number, guys? In the chat, please. Again, if you are afraid of making a mistake, don't worry. I'm not saying names. I'm not saying, hey, you did it wrong. I'm not saying names, right? So don't worry about it. Beautiful. Thank you. Right. I have like 9 answers, and all of you are correct. The next number here is -1. Beautiful. If I ask you to write the next one from this, what would be? What would it be? The following will be beautiful. Some people got it already. 1. Okay, so look at that. This organization doesn't even have a plus or minus or plus or minus. No, this organization is just an array of numbers from positive to negative. Look, +1, -1, +1, -1, +1, -1, +1, -1, +1, -1, and so on and so forth, right? That is a sequence. How about this one? This one is pretty hard, right? What would be the next number, please, in this one? Okay, for the people who are not understanding how people are getting these numbers, let me show you again. The only idea, the only real process here is to think about what connects the first number to the second, and the second to the third, and the third to the fourth, and so on. And some people might realize that from here, from the first number, all I have to do to get the second one is subtract 25. 100 minus 25 is 75. What do I do from the second number to get the third? Look at that. It happens to be that I have to do the same, minus 25. 75 minus 25 is 50. Could it be? Could that be the connection? Then again, from 50 to 25, all I have to do is subtract 25. And look at that. The connection carries on. What makes everybody think that the next one will be the result of subtracting 25 again. And people will be correct. The next number is, in fact, 0. Beautiful, guys. If I ask you for the next one, which one will it be? The next number in here. Well, all I have to do is carry the connection, right? Continue with the process. So just subtract 25 again. But if I subtract 25, that is 0 minus 25, then the next number will be -25. Congratulations to the people who wrote the answer in the chat. Thank you, guys. That is it. Those are sequences. Let's continue with the last 3. See what people think about these ones. Can you recognize the next number in here? Ooh, that one is interesting. That one is interesting. Nobody? Just 2 people? Give it a try. Just see a connection. Look for a connection. Once you find it, write it down. Write it down. If you are correct, congratulations. If you are wrong, then I'm not gonna say anything. Nobody's gonna know. We are the same, right? Don't be ashamed. Look for a connection and write it down. Okay, I have like 3 different possibilities in here. And that is because this could be understood in 3 different ways, or 4 or 5 different ways. This one, in all honesty, I'm being honest, this one here is one of the hardest sequences that we can find. I decided to write this down as an example because it is not clear which is the connection. Some people may say, all right, look, in here I just add a 1 plus 1. And for the second one, I'll add a 1 again. So here I add a 1. No, I add 2. What? And here I add 3. So what do I add next? What is the connection? Do I add 4? Do I add 3 again? Because here the ones are repeating. What do I do? It's not hard. It's not easy to understand this. Some people might say, all right, look, this is the result, each number is the result of adding the 2 previous to this. So 3 is 1 plus 2. 5 is 2 plus 3. 8 is 3 plus 5. Did you see? And that is another possibility. So in this one, we don't really know which one is the one that continues. We don't know. So I'm going to do this one. Because we don't know. I don't know. But what about the next one? That one is pretty simple, right? That one is pretty simple. What is the number that comes next in this one, guys? That one is pretty simple. Okay, I have 1 person, 2 people already saying the answer. Give it a try, guys. Look for a connection. The study of sequences is the study of connections. Look for a connection. That's it. Lau Ávila says, profe, Majo C no se ha podido conectar por el internet. Thank you, Lau. Thank you for letting me know. Thank you. Appreciate it. All right, 3 people. I have 3 answers. Again, look for a connection, guys. Don't be wasting your time, please. Don't be just looking at the cell phone. Don't be just looking at, I don't know, eating breakfast. Do that. Do that if you want to. But also, try the exercises. Look for a connection. There has to be a connection somewhere, right? There has to be a connection. All right. The connection here is pretty simple. All I have to do is multiply times 2. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. So 8 times 2 will be the next number, 16. And if I do it again, I will have 32. And so on. Right? Last sequence of the examples. This one over here. Which is the following number? Man, I love it when you guys try it. I love it when you guys try it. There you go. We have some answers now. Beautiful. Beautiful. Thank you. Thank you for trying. All right. You guys will be correct. The people who said 5/6. Look at this. Look at the connection. In this case, this connection doesn't have to do with additions or subtractions or multiplications in the middle. This is just 1/2 and then carry the 2 to put it on top, right? Then 2/3 and then carry the 3 to put it on top. 2/4. Carry the 4 to put it on top. 4/5. Did you see? 1, 2, 2, 3, 3, 4, 4, 5. So 5, 6. And then 6/7 and then 7/8 and so on. These are also a different type of sequences, right? Okay, Go ahead in the chat, guys, please let me know. Is this topic hard? Yes or no? Is it hard or is it easy? Thank you. All right, thank you. I have some answers. All right. I have a problem with these guys. We have 29 people in the class. We have 29 people in the class. And only, what, about 12 are participating? About 12 people are participating. I need all of you guys to write in the chat, please. All of you. Spend the time, right? Spend the time. Turn on the cell phone, activate the little keys, and write easy or write hard.
Mister, es que no tenía internet, que estamos
It's okay,
viendo.
Majo. It's all right.
Perdón.
Majo, look, this is the topic, sequences, all right? The topic is absolutely easy. You are pretty good in math, so I'm sure you will be okay. Nonetheless, if you have difficulties, you can always go back to this recording. I'm recording the class right now, all right? So you can always look it back, all right?
Okay, thank you,
Absolutely.
Mister.
All right. Beautiful. These are sequences, and each and every one of these is a different type of sequence. We are going to study, all of us are going to study one specific type of sequence. One. Just today. Maybe in the future we study another one. And maybe from there we study some other types. We will begin with the easiest types of sequences. These sequences are called arithmetic. Arithmetic sequences. Go ahead and write it down. That is the name of the sequences. Secuencias aritméticas. Este es su topic. Esto es un tema también para el del saber 11. Entonces, si lo llegan a encontrar, se llaman así, secuencias aritméticas. ¿Listo? En algunos casos, en algunos libros, en vez de llamarlas secuencias, las llaman sucesiones. Es exactamente lo mismo. Es una organización de numeritos uno después del otro. Tienen algún tipo de conexión los numeritos. Una secuencia aritmética o una sucesión aritmética. All right, arithmetic, TH, arithmetic sequences. Those are the ones that we are going to study. Now, which ones are those? Pretty simple. Arithmetic sequences are the ones that have a difference, that have a constant difference. Difference. Now, what do I mean by a constant difference? Again, arithmetic sequences are the ones that have a constant difference. Go ahead and write it down. You can always go back to the recording if you want to, if you don't want to take notes. But I advise you to take notes about this, all right? What is a constant difference? This is a constant difference. Look, when every change from one number to the other is constant, then that is the difference. In here, the first one is an arithmetic sequence. Because from 3 to 8, all I have to do is add a 5. From 8 to 13, all I have to do is add a 5. Look, the difference between 3 and 8 is constant between every single number. From 3 to 8 is the same difference than from 8 to 13, which is the same difference than from 13 to 18. Again, same difference from 18 to 23. The same difference. That is the idea behind constant. Is the same. And difference means the result of subtracting these two numbers. So we are looking for differences that are the same in every step. This is an example of a sequence that is not arithmetic. Look, we have a difference here. The difference is 1. But it's not constant. Remember, constant means is the same. It carries on. And you don't have the same difference here. One is plus 1, the other one is plus 2. So the difference are this. The difference are different. The differences are not the same. All right? This is not an arithmetic sequence. This one is an arithmetic sequence. How about this one? Is this an arithmetic sequence or not? Go ahead and write it in the chat, please. Tell me if this is an arithmetic sequence or not. All right, let's see. Thank you for writing in the chat, the people who are answering. Thank you, guys. Thank you for participating. Thank you for not letting me feel alone. Thank you, guys. Okay, let's see if this is an arithmetic sequence or not. How do we see if that is an arithmetic sequence? Simple. We need to look for the difference and then see if that difference is constant. That is what we have to do. So let's think about the difference between the first number and the second. What is the difference? In other words, what is the subtraction here? If I do -1 minus 1, that is what I'm doing. Let me erase this, okay? We know this one is not as an arithmetic sequence. I'm going to erase it so that I can write it in here, all right? The difference, I'm going to write it D. In every single book, you're going to find the word difference as a D, all right? For the first example, the difference was 5. So I'm going to write D equals 5. All right? And how did we know that? Pretty simple. All we had to do was subtract the second position, 8, minus the first position, 3. Second position minus the first position. That is the way you find differences. Subtract the second minus the first one. 8 minus 3, that is a 5, right? Which is what we knew from the beginning. The difference was 5. But let's think about the difference in this one. Let's think about the difference in this sequence over here. If I do the second term minus the first one, I have -1 minus the first one. Did you see? -1 is the second position, minus the first one, which is the first position. Right? And this subtraction will give us -2. In other words, the first difference will be, let me erase all of this. The first difference will be -2 to pass from one number to the other one, -2, right? Does that difference carries on? Let's see. Let's try to find the difference in the second one. Again, take the following number minus the previous one. So I have 1, which is the following number, minus the previous one. So -1. Again, this -1 is the previous number. Did you see what I did? I have a double negative now. The negative of the subtraction and the negative of the number. Is this difference -2? 1 minus -1, that is +2. Not negative, that is positive, right? So the difference between these two numbers, here, the difference between these two numbers is +2. Not -2, +2. So there is a difference. Look at that. There is a difference. From the first number to the second, we just do -2. From the second to the third, we just add 2. If we continue this process, we will have the same. Then we have -2 here, and then +2 here, and -2, and +2, right? But is this, guys, is this difference constant or not? In other words, is the difference the same always? No. Okay, the number is, but the sign is not. And the difference has to be with everything, number and sign. The difference in here is not the same. In order for this sequence to be an arithmetic sequence, I had to have every single difference constant. Every single difference to be the same. -2 and then -2 again, -2 and then -2 again. And then, did you see? This is an example of a sequence that is not an arithmetic sequence. This is not an arithmetic sequence, guys. All right? Go ahead and write it down in your notebooks or something, please. Juan Sebastián Grau says, profe, cuando acabe la clase, ¿puedo hablar un momento con usted? Absolutely, brother. Absolutely. Yes, absolutely. You can. Absolutely. Where's my eraser here? Okay, let's continue. How about the third one? The fourth, because I erased one over here. The fourth sequence here. Is this an arithmetic sequence? Yes or no? Please, in the chat. For the people who are still not getting what is the idea behind an arithmetic sequence, again, you need to look for the constant difference. So the subtraction between the first two numbers and this other two and the next two and the next two and the next two, that subtraction is the difference. And the idea behind constant, look, constant difference, is that every single difference has to be the same. If that happens, then we have an arithmetic sequence. Beautiful. So, is this an arithmetic sequence or not? Everybody in the chat are saying yes. And you guys are correct. This is an arithmetic sequence. Let me erase the second one. This is not a sequence we want. Here, what is the difference between 75 and 100? Again, to find the difference between two numbers, you just subtract them. So you do 75 minus 100. The second one minus the first one, right? This difference in this case is -25. Beautiful. We knew it from the beginning. Look, -25. We knew it. We did it mentally, huh? For the second one, again, 50 minus the one previous, so 75. You do just that process. You take one and subtract it to the second one. Take one and subtract it to the previous one. Sorry, to the previous one. Takes one and subtract it to the previous one. In this case, the subtraction would be -25. If you do the process, you see that every single difference is constant. We have it in here. -25, -25, -25, -25, -25. This is an arithmetic sequence. When you guys are presenting your examination in November in the following year, or I don't know, maybe the next class, maybe we have a quiz about this. When you guys are presenting a quiz about this, this will be the first challenge. To separate the sequences that are arithmetic from the ones that are not arithmetic. That is the first challenge. All right, let's continue with the next one. This one, is this an arithmetic sequence or not? In the chat, please. Beautiful. Thank you for participating. Man, I have a lot of people participating today. Thank you. I appreciate it. Thank you. Remember, we have a lot of people in the class. Take the time, guys. Please. You are looking at my class through some device, right? Either from your computer, from an iPad, from your cell phone. Take the time. Activate the little keys and write. Yes, right. No. Thank you for participating, guys. You are correct. This is not an arithmetic sequence. This is not an arithmetic sequence. Again, same process. If you think about the differences are not constant. The difference here is +1. The difference here is +2. I'm sorry, +1. So you would say, hey, look, it's constant. I have +1 and +1. But then with 3 and 5, it's +2. not constant anymore. And then from 3 to 8 plus 3, not constant anymore, right? Okay. This one, not an arithmetic sequence. The next one, is this an arithmetic sequence? Yes or no? Let's see in the chat. Is it or not? Ooh. Beautiful. We have a lot of people saying yes. Now let's think about it. Here is a problem with mathematics. Mathematics teachers, we love to do this to students. We love to write down and play with your mind. We love to write down little keys in here to make you think things that are not there. Because now you say, look, times 2, times 2, times 2, it is constant. It has to be an arithmetic sequence. It has to be. Is it? Guys, the idea is not that the number is always the same. The idea is that the subtraction is always the same. Here you have a times 2. Here you have a times 2, a times 2. That is constant. Yes, but is that a difference? If we think about the differences, again, remember, to find the difference, we just take the first two numbers, the second minus the first one, right? So we do 2 minus 1. The difference in this case is 1, right? So we have a difference of 1 in here. Let me say this is difference 1. I'm saying this is the difference between this number and this one. Okay, let's find the difference 2. So the second difference, I'm now thinking about this second difference. Is that the same? To find the difference, take the number and then subtract it to the one previous. So that is 4 minus 2. And the difference here is 2. So guys, is the difference constant? Nope. Here, the multiplication, the ratio is constant. But the difference is not. Again, guys, if you like to take notes in your notebook, if you do like this, write it as a note. Note. And put it in a something, in a triangle, in a heart, I don't know, write it somehow. Write it. It's not just about having the same number. It's not. It's about noticing if that number is also a difference. Okay? This one is not an arithmetic sequence. All right. Beautiful. And last but not least, for all the people who love doing operations with fractionaries, is that an arithmetic sequence or no? Now you might be thinking, don't just jump into saying no. Don't just jump into saying no, because you're saying, all right, 1 over 2, 2 over 3. Come on, that cannot have the same difference. Don't just jump into conclusions, guys. No. Think about the difference. Find the difference behind these two numbers. And then find the difference behind these two. And then the difference behind these two, sorry. Now, you can do it by hand, or you can do it with the calculator. Still, 2 over 3 minus 1 over 2, right? 2 over 3 minus 1 over 2. Just do that in the calculator. Write down the difference as I did here. And then you tell me if this is an arithmetic sequence or not. Okay. All right. Okay. Okay. Okay, either you guys had your calculator with you at the beginning, or you guys are not doing nothing. Because the only person I saw standing up for the calculator was Sebas Moreno. That was the only person I saw standing up for the calculator. So either you have the calculator with you or you're doing nothing. Which one is it, guys? All right, let's see. I want you guys to help me with this. Tell me which one is difference 1. Again, D1 makes reference to the first difference. This will be D1, all right? How much is that, guys? Please tell me. How much did it give you in your calculator? This will be 3, 6, 3, 6. Nobody? $1.6. Thank you. 1.6 or 1/6? Which one? 1/6, maybe? Right? If I amplify this is 3/6. Right? This is 4/6. 4 minus 3 is 1. 1/6, right? 1/6. Beautiful. Let's think about the difference 2. Now, again, difference 2 makes reference to this second difference. Is the difference the same or not? All right, if I amplify this is over 12. So 8/12, 9/12. So 1/12, right? 1/12. Okay. Guys, from there, we don't have to continue. Because look, difference 1 and difference 2 are not the same. Sure, the first number is the same. We have 1 over something, and here we have 1 over something. So the first number is the same. But every difference, the entire difference, has to be the same over the whole sequence. So just by doing the first 2, we notice the difference are not constant. So this, I'm not going to say it. You guys are going to say it. Is this an arithmetic sequence? Yes or no? Thank you, guys. Thank you to all of you who are working in my class, who are taking the time, write it down, yes or no. This is the way you guys learn mathematics. You don't learn mathematics by listening to your teacher and looking at a board. That is not the way you learn mathematics. You learn mathematics by doing. So thank you to all of you who are participating. Thank you, guys. All right. Yes, this is not an arithmetic sequence. This is not an arithmetic sequence. Now, before we continue, I think it was Paul who asked a question in the chat. Yes, Paul. Paul says, Profe, por decimales también se puede hacer, ¿no? Yes, brother, yes. You can have decimals in the differences. You can have decimals there. For example, this. How much is 1/6? Man, no idea. How much is 1/6? Can anybody help me, please, in the chat? I need 1/6 and 1/12, please. 0.16. Man, I'm good, right? I'm good. And then 1/12. That divided by 2, right? So 0.050308. Man, on fire, right? Okay, I'm gonna tell you something. When your teacher is faster than the calculator, you know your teacher is good. You know your teacher is good. You know that. All right, let's continue. So yes, Paul, you can have differences and you can just look and analyze the differences. In this case, this difference is not the same than this, right? Differences are different. So not an arithmetic sequence. But also, you can also have this type of sequence, a sequence that contains decimals. This one in here. Let me just write it down. I don't know, 3.1, comma, 5.2, comma, 7.3, comma, and so on, right? That could also be a sequence. The sequence contains decimal numbers, And all we have to do to analyze if this is arithmetic or not is the same process. Subtract to find the difference and find if the difference is constant or not. Just as an example, is this an arithmetic sequence or not? Is it or not, guys? Again, take the time, take out the calculator, find the difference, and tell me, are they the same or not? Okay, for the people who are not looking, who are not seeing it, the first difference will be 5.2 minus 3.1. Again, the second number minus the first one. Second minus the first. This difference, you just take out your calculator. If you cannot do it in the mind, it's okay. This will be 2.1, right? That is the first difference. Then find the second difference. Third number minus the second. So this is 7.3 minus, minus, not subtracted, sorry. 7.3 minus 5.2. This difference is exactly 2.1. Okay? So just from these three numbers, this is an arithmetic sequence because the difference are the same. Now, if I write a fourth number like this, that is the fourth number, 8. If I do that, I have to find the third difference. Every difference has to be constant in the sequence. So I have to find every single difference. If I do that, I have to do 8 minus 7.3. This difference is exactly 0.7. In other words, this 8 makes it so that this sequence is no longer arithmetic. This one now is not. All right, guys? Make sure you look for every single difference. Every single difference has to be constant. This one is constant with this. This one is constant, but they're not constant with the third one, right? These two are constant, but this is not. Every single difference has to be the same. So in that case, it is not an arithmetic sequence. All right, guys. Beautiful stuff here. Beautiful stuff here. How you guys are doing with this topic? Please let me know. How are you guys doing with this topic? Please. Are you guys understanding? Are you guys completely lost? How are you guys doing? María José Gutiérrez says, perdón, mi internet está medio pichis. It's okay, Majo. Look, I am recording the class, so you can always go back to it if you go and look at the videos, all right? So it's okay, Majo. It's okay. Where is Danny? Danny, I don't remember the last name. Danny Perez, there you are. Thank you, Danny. Haven't seen you in the chat today. Sí, ustedes pensarán que no, pero cada vez que ustedes escriben, mis niños, yo reviso quién está escribiendo. Y claro, uno que otro se me pasará. Hay muchos que no me recuerdo los nombres, en la realidad los recuerdo sus caritas, pero hay muchos que los nombres no recuerdo. Pero hay otros que recuerdo los nombres. Entonces, cuando yo voy leyendo, voy mirando, mira, esta ya respondió, este aquí no ha respondido, mira aquí. Y yo no digo nada, pero sí reviso. All right. Let's continue with the topic, guys. Let's continue with the topic. Dani, es porque estoy dándole desayuno a mis hermanas, profe, perdón. It's okay, Dani. It's all right. It's okay. As long as you are paying attention, you can do whatever else you need, all right? As long as you are paying attention, it's okay, Dani. All right. So we have in the board, we have two arithmetic sequences. All right. We have two arithmetic sequences. Beautiful. Now, let's study what are the parts of an arithmetic sequence. Beautiful. The first part is the difference. The difference is called D. We know that already. We have been finding differences so far. Now, how do you find the difference in a sequence? It's pretty simple. You just take one position minus the previous before, right? Now, when we talk about positions, we need to make sure we are talking about the same position over and over. So when we talk about positions, we mathematicians like to call them in the same way. We like to call them using letters and numbers. For the first position, we are going to take one number, and now this sequence is called after that, I'm sorry, one letter. And now this sequence is called after this letter. So right now, this sequence is the sequence A. All right? Let's say that I want this sequence to be called the sequence W. So the first position will be the position W. All right? The name of the sequence is given by the letter we are using. This is not new. In mathematics, before vacations, we saw something like this. Some functions are called f of x equals, I don't know, 3x plus 1. And then some other functions are called g of x equals 2x. I don't know, right? These are the names of the functions. The first function is called f. The second function is called g. And we write them with letters because we like to know which function are we talking about. So just like we do it with functions, we do it also with sequences. Sequence A, sequence W. The problem is we don't only have one position. This A is for the first position, but we have a lot of other positions. So what other numbers or letters are we going to write? Same problem with the W. Because you could say this is A and this is B, just following the order, right? So A, B, C, D, E. You could say that. But what about this one? I begin with the W. So I can say W, X, Y, Z. And what do I do here? A again? You know, that comes with a problem. So we mathematicians decided to call every single position after the name of the sequence. If this is A, then this is also A. And this is also A, and this is also A, and this is also A, and this is also A. Every single position is the position A, but the difference between these A's is the number of the position. This is the first A, so A sub 1. This is the second A, so A sub 2. 3, the third A, the fourth A, the fifth A, and the sixth A. The little number under the letter is showing the position of the sequence. So if I say, guys, what is the value of A sub 4? Which one is that? Well, that is the sequence A, the position 4. Again, sequence A, position 4. This is the sequence A, so 1, 2, 3, 4. Position 4, so the number is 18. Did you get it, guys? Let's see if you did. Answer this one for me, please. W3. W sub 3. How much is that in the chat, please? Mafe Villamil says, profe, y también se podría A1, A2, A3. Muy bien, Mafe. Es exactamente lo que acaba de hacer. Muy bien, Mafe. Le pegaste perfecto, mi niña. Muy bien. Muy bien, Mafe. All right. W sub 3. How much is this? Congratulations to the just 5 people who are answering. Again, we have 29 people. No, one of those is me. 2 of those are me because I have 2 cameras. 20 something, 25, around 25 people are in the class. So please, those 25 people, take your time, activate the keys, and write the solution. Please, don't be lazy. All right. W sub 3. Again, What is this? Okay, this is the sequence W, and we know this is the sequence W, so we're talking about this one. Sequence W, position 3. 1, 2, and 3. So this is 50. Pretty good, guys. Pretty good. You guys are correct. You guys are correct. Pretty good. So that is the position. Again, so this will be position W1, right? W2, W3, W4, W5, W6, right? Beautiful. Again, to find the difference, now that we are talking about positions, we can also talk about positions to find a difference. So the difference of this, let me write it here. The difference of this sequence, it's constant, right? And will be the result of taking one position, for example, position 5, minus the previous. I take the sequence A, the position 5, minus the sequence A, position 4. That difference have to be the difference of everyone in here, if it is arithmetic, right? Again, every one of these numbers means sequence and position. In here, I am doing 23 minus 18, right? To write it as a formula, instead of writing the exact position, we just write 1 like this, n, and then n minus 1. What that means is that now I am not talking about a specific position. I am saying any position. In mathematics, n means any. Whatever you want. So any position subtracted to the position before that one. So if I say n is 6, I'm subtracting it to position 5. Did you see? N minus 1. 6. 6 minus 1 is 5. So I'm doing A6 minus A5. And that works for everybody. This will be the formula to find differences. Go ahead and write it down, please. That would be the formula to find differences. Although, we don't need it, right? We don't need it because we have been finding differences without using that formula. We have been doing differences just by analyzing, just by thinking. Sometimes we don't need formulas. Sometimes we don't need formulas. All right, beautiful. Let me raise this thing over here. La, 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 la. Let me ask you a question, guys. Let's see who gets it. Let's see who gets this one. How much is A10? How much is this, guys? Let's say that is the quiz. That is the quiz. For example, that is the quiz. How would you solve it? How will you solve it? How much is A10? Okay, I can see some faces thinking, what? Think about what A10 represents. A means we are talking about the sequence A. This one in here is the sequence A, right? So we can discard this one. Forget about this one. We are talking about this one in here. And 10 means the position. So we are looking at the number that is in the 10th position. This is the number in the first, in the second, in the third, in the fourth, in the fifth, in the sixth. Meaning we need to find this one that comes here, the 7th position, right? The 8th position, the 9th position, and then the 10th position. This one is the one we are looking for, A10. That one is the one we are looking for. All we have to do is continue the process, right? And we know A10 will be 45. Also, I don't know, to be honest. All I'm doing is writing your answer. 48, sorry, 48. I'm writing your answers. I don't know, to be honest. I don't know. But can I find out? Well, yes. All I have to do is do the process, right? So from here, if I add 5, that is the addition, right? That is the difference. 5, 5, 5. So if I add 5, will be 33, and then plus 5, so 38, right? And this then plus 5, so 43, right? And then plus 5, so 48. You guys are correct. 8, 10 is 48. Beautiful. Beautiful. Yes. How about this one? How about that one? I feel like all of us understood what is this, right? And none of us is willing to do this process to the 100th position, right? None of us is willing. Man, I don't want to do it. I like math and I don't want to do it. How about this one? Man, forget about this. I'm done. I don't want it. I wish there was an easier way to find these ones. I wish there was a little formula to find these ones without having to do the entire process, without having to do the 999 previous to this. There is. And to show you that, I am going to use this one over here, this sequence. Paul Camargo says, 2400 es igual a A sobre 1000, ¿no? A sub 1000. Honestamente no sé, papá, honestamente. ¿Puede ser? De pronto no. ya veremos, ¿listo? Para este ejemplito, voy a hacerlo en españolito, porque aquí es donde la gente se me pierde. Este es el único momento donde la gente se me pierde. Si van al libro, van a encontrar la fórmula para lo que yo acabo de hacer. Ahí está. Bonita, sencilla. Pero yo no solo quiero darles la fórmula, sino quiero darles el por qué demonios esa fórmula es como es. ¿Por qué? ¿Por qué a alguien se le ocurrió eso? Y es una vaina tan simple, tan sencillita, que se las puedo mostrar por acá. Pero si lo hago en inglés, a veces la gente se me pierde, ¿listo? Entonces voy a hacerlo en españolito, ¿está bien? Voy a hacerlo en españolito. 5 minuticos de español. ¿Está bien, mis niños? No se me pongan bravos, por favor. Ahorita volvemos al inglés. ¿Listo? A ver. Voy a escribir esta secuencia en este orden, para que quede un poquitín más fácil. Mira, este es 3 y luego 8 y seguía el 13, ¿cierto? ¿Cuál era el que seguía? Más 5, ¿no? Entonces 18 y luego 23, etc. Vamos a escribir aquí. Esto es la posición 1, esta es la posición 2, la posición 3, posición 4 y posición 5, ¿cierto? Digamos, yo sé que quiero encontrar la posición 1000. Ese es el ejercicio original. A sub 1000. Ese es el que queremos encontrar. Pero a veces, antes de poder volar hasta el 1000, tenemos que saber correr, caminar, gatear. Hagámoslo chiquito. ¿Qué tal si encontramos una sencillita? Hagámonos a 10. Ya sabemos la respuesta, ¿sí o no? Ya sabemos que A sub 10 era 48. Entonces miremos a ver si pudiésemos encontrar una formulita que nos funcione con A sub 10. ¿Será que podemos o no? A ver, enfóquese cámara, por favor. Ok, entonces digamos que queremos encontrar A sub 10. Lo bonito de esto es que si yo reescribo esto de esta manera, me doy cuenta que hay una regularidad. Mira, del 3 paso al 8, ¿cierto? O sea que yo puedo escribir el 8 como 3 más 5. ¿Por qué lo quise escribir así? Porque hay una diferencia entre 3 y 8, que es 5, ¿cierto? Lo mismo pasa para la tercera. La 13 es 8 más 5, ¿sí o no? El número anterior más la diferencia, ¿cierto que sí? Esa es la idea de una aritmética, ¿cierto? Una secuencia aritmética. El número anterior más la diferencia. ¿Me van siguiendo, mis niños? Me van la cabecita, escríbanme así en el chat, háganme así, tranquilos. Ok, cool, listo, bien, listo. Pero mira tan bonito, yo acabé de decir que el número 8 se puede escribir como 3 más 5. ¿Qué tal si entonces escribo este 8 como 3 más 5? Entonces me quedaría 3 más 5 más 5. ¿Sí o no? 8, que es 3 más 5, más el 5 que tenía acá. ¿Sí lo están viendo o no? O sea que, mira, y si somos organizaditos en matemáticas, 5 más 5, eso es 10. O sea que esto es 3 más 10. ¿Por qué hice este cambio así? Porque ahora la tercera posición está escrita con base a la primera. O sea que si yo quisiera encontrar la tercera posición, solo necesito tener la primera. 3 más un número. ¿Para qué hago esto? Lo mismo aquí. Aquí puedo encontrar el número 18, la cuarta posición, solo con base a la primera. Esto es 3 más algo. Pero ¿cuánto es ese algo? Ok, pensemos en cuánto es ese algo. Mira, vamos a hacer el mismo proceso a ver si ya se van dando cuenta. Yo creo que uno que otro ya más o menos lo está viendo. Este 18 es el anterior, que son 13 más 5, ¿sí o no? 13 más 5. Pero yo acabé de decir que 13 se escribía como 3 más 10, ¿cierto? Mira, eso es lo que hice aquí. 13 es esto, ¿qué es esto? ¿Qué es esto? 13 es 3 más 10, o sea que esto es 3 más 10 más 5. El 5 de acá, ¿sí o no? ¿Sí lo están viendo? Para que quede más bonito, esto sería 3 más 15. 10 y 5. 3 más 15. El primer numerito, el primer posición, 3, la primera posición, más un numerito, 3 más 15. Lo mismo aquí. Esto es 3 más. ¿Alguien ya vio el orden? 3 más 5 para la segunda, 3 más 10 para la tercera, 3 más 15 para la cuarta, 3 más qué para la quinta, 3 más qué, 3 más 20. ¿Sí o no? Y es que lo que estamos haciendo es que en este caso, esto era 5 por 1, en este caso era 5 por 2, aquí era 5 por 3, aquí era 5 por 4. ¿Por qué puse un 5? Porque es que 5 es la diferencia. Y la diferencia la obtenemos rapidito. Para la quinta posición, multiplico la diferencia por 4. Para la cuarta posición, multiplico la diferencia por 3. O sea, uno anterior. Para la tercera posición, multiplico la diferencia por 2. Uno anterior. ¿Eh? ¿Cómo será entonces para el... Ahí se me cayó. ¿Cómo será entonces para el A sub 10? Pues esto es 3, el primer numerito, porque eso es lo que hemos venido haciendo, 3 más algo. ¿Más qué? La diferencia 5 por, aquí era 5 por 1, 5 por 2, 5 por 3, 5 por 4. ¿5 por qué será aquí? Aquí 5 por 9, uno anterior al 10. ¿Será que esto nos da o no? ¿Cuánto es 5 por 9? Es 45, ¿cierto? Más 3. Ay, hijo de madre, sí nos dio. Ay, hijo de madre, sí nos dio. O sea, ¿qué ahora podemos encontrar? Ahora hagámonos esta. Hagámonos esta. ¿Cuánto es A sub 100? ¿Cuánto es eso? ¿Cuánto es A sub 100? Pues es el primer numerito a la primera posición, 3, más algo. ¿Pero más qué? Pues más la diferencia que era 5 por... ¿Y aquí cuál pongo? ¿Por cuánto? Que mira, para la posición 10 puse por 9. Para la posición 5 puse por 4. Por 4. Para la posición 4 puse por 3. Para la posición 3 puse por 2. O sea, me estoy regresando 1. O sea, 5 por 99. Metemos esto en la calculadora y ¿cuánto nos da? ¿Cuánto nos da eso, muchachos, por favor? 5 por 99. Bueno, más 3, ¿no? Esto sería 495. En vez de hacer las 99 posiciones anteriores a esta, con ayuda de esa medio formulita encontré cuál era el valor. Hagámosle un paso más a ver si ya alguien lo vio. La que nos queríamos preguntar al inicio. A sub 1000.
Profe,
Sí.
profe es 498. ¿Por qué no le sumo el
Ay,
3?
hijo de madre, no le sumé el 3. Gracias, mi niña, gracias. Eres muy amable. No le sumé el 3. Gracias, mi niña. Gracias, Mafe. Ok. La que sigue. Por 1000. A sub 1000. Mismo orden, ¿no? El primer numerito, el 3, más nuestra diferencia multiplicada 999 veces. ¿Cuánto es esto, por favor? ¿Alguien ya lo hizo? 4998. La belleza de los números es que cuando estábamos en las cuevas y no teníamos fuego, aprendimos a crear el fuego y nos dio herramientas. Un poco de tiempo después aprendimos a contar y nos dio herramientas. Y un poco después aprendimos la matemática, ya no tenemos que volver a contar. Contar es feo. A nadie le gusta contar. Hacer planas es una mamera. Pero nosotros no tenemos que hacer planas porque podemos matemáticas. En vez de encontrar 999 números anteriores a estos, encontramos solo un numerito. Paul says, profe, pero esto es para un sistema aritmético. ¿Aritmético? Pregunta. ¿Un sistema aritmético? ¿O también sirve para el otro? Porque esta diferencia siempre es igual. Perfecto, papá. Muy bien. Esto de aquí se basa en que la diferencia, mira, 5 y 5 y 5 y 5. Mira que la diferencia que estoy poniendo siempre es la misma. Una diferencia constante. La idea detrás de esta organización es que hay una secuencia aritmética donde la diferencia no sea constante, o sea, no sea una secuencia aritmética, los números 3, 8, 13, digamos que estos números no fuesen secuencia aritmética, pues la diferencia no sería la misma. Aquí sería 5, y aquí de pronto 6, y aquí de pronto 7, y aquí de pronto 8. Otra secuencia. Luego entonces no puedo organizarlo de esta manera. El truquito, la formulita, no me sirve. Tiene que haber otra. Pero esta ya no es. Esta formulita, este truquito, sirve solo para secuencias aritméticas. Ok. Vamos ahora a tratar de reescribir esto en una... ¿cómo lo pongo? Yo creo que lo puedo hacer aquí. En una formulita, ¿listo? Vamos a pasar a la parte chévere. Vamos a pasar a la parte chévere. Ahora vamos a hacerlo sin números. Digamos, mis niños, que tenemos una secuencia de esta manera. A sub 1, A sub 2, A sub 3, puntos suspensivos. ¿Listo? Es una... Ahí no se alcanza a ver, perdónenme. La voy a hacer una línea más abajo. A sub 1, A sub 2, A sub 3, puntos suspensivos. Mejor. Tenemos una secuencia que no tenemos ni idea los números que son. Ya no estamos hablando de esta específica, 3, 8, 13, 18, 23. No, estamos hablando de cualquiera que resulte que sea secuencia aritmética. Por ejemplo, ¿se acuerdan la secuencia W que estaba aquí? Esa podría ser esta. Esa podría ser esta. El primer número era 100, el segundo era 75, el segundo era 50. Esa también es secuencia aritmética, ¿sí o no? Claro, la diferencia es negativa. Claro, pero también es aritmética. Entonces también nos va a servir lo que vamos a hacer a continuación. Vamos a encontrar la fórmula. Ya no un truquito, no, la fórmula. ¿Cómo se hace? Muy fácil, póngale cuidado. A ver si puedo escribirlo aquí. El segundo A, el A sub 2, se puede escribir como A sub 1 más la diferencia, ¿sí o no? Mira que ahora estoy usando letras. Ahora estoy usando letras que sabemos que significan algo. A sub 1 es la posición 1 y D significa la diferencia, ¿listo? ¿Cuál diferencia? La diferencia asociada a esa secuencia. En este caso era 5, por eso tenemos 3 más 5. ¿Me van siguiendo, mis niños? Muevan la cabeza, háganme una así, escríbanme en el chat. Ok, listo, bien. Listo, listo. ¿Cómo quedaría la tercera posición? El A sub 3. Ok. Siguiendo el mismo orden, mira que el A sub 3 era 3 más 5 por 2. O sea, la primera posición más 2 veces la diferencia. ¿Cierto que sí? 5 por 2 es 10 y era 2 veces la diferencia, 5 por 2. ¿Cómo quedaría A sub 4? Pues es el primera posición más 3 veces la diferencia, ¿cierto? Y si yo expando esto y lo mantengo, voy a encontrar que para cualquier posición, recuerden, en matemáticas cualquiera se escribe n, o sea, la posición 10 o la posición 100 o la posición 1000, cualquiera, va a estar dada de esta manera. Mira, 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 mira. A sub 1, o sea, el primer numerito, mira, aquí era 3, 3, 3. El primer numerito más la diferencia multiplicada por algo. ¿Cuántas veces multiplico la diferencia? Ok, para la posición 4 era 3, para la posición 3 era 2, para la posición 10 era 9, para la posición 100 era 99, ¿cierto? O sea, tengo que tomar la posición y restarle 1. O sea, esto es n menos 1 por la diferencia. Y esta, mis niños, esta de acá, esta de aquí, es la fórmula para encontrar la posición que queramos. La que queramos. En cualquier secuencia aritmética. La que sea. Yo lo hice con un ejemplo, una secuencia específica, pero funciona para cualquiera. ¿Quién es n? Pues es la posición que queremos encontrar. En nuestro caso, n sería 1000. ¿Quién es a sub 1? Bueno, pues esto es la primera posición de la secuencia. ¿Quién es d? Ok, pues d es la diferencia, la restica, que es constante. En nuestro primer caso era 5. Y ya estuvo. Let's go back to English now. The piece of Spanish is over. So, did you guys write this down? Did you guys write it down or not? Beautiful. All right. Let's use this in some exercises. Let's use this in some exercises. In here, I have the book. Let me see if I have some examples around here or not. Here. Beautiful. I want an easier one. I want an easier one. This one. All right, let me show you this. All right. Did you see, guys? Look. This was the formula. It was in the book all alone. It was in the book all alone. The only difference here is that the sequence is called U in this case. Remember, the big letter is the number, is the name of the sequence, right? I choose to call mine A. The book is choosing to call the sequence U. But it is the same formula. Look, the position A is equal to the first position plus n minus 1 times the difference, right? It's the same formula, right? Let's go ahead and try this one, this exercise, please. A, B, C, and D, all right? I want you to try it. Try it yourselves, guys. Give it a try yourselves. I am going to do it in the board, all right? I'm going to do it in the board, but only after a couple of minutes. Give it a try, all right? Give it a try, guys. You can always use a calculator if you want to, okay? You can always use a calculator if you want to. There. Okay, let's take a look at the question. The first term of an arithmetic sequence is 5. Beautiful. Let's switch to this organization. Okay, I have this for a reason. Tablero y diapositiva, no. Tablero y libro, no. Tablero y libro. There. Beautiful. Let's say 100. Beautiful. Even better. 150. Yes. All right. Now you can see me and the book at the same time. Look at that. Haven't used this in a while. All right. Let's take a look at the question. The first term of an arithmetic sequence is 5. So we know one thing. You can use any name for the sequence. A, B, C, whatever. You as the book, whatever. I like to use A. So I know that A1 is, which one? Is 5, right? The first term of an arithmetic sequence is 5. That is what it says, right? And the common difference, so in other words, V is 2 over 3. 2 over 3, right? That is the difference. Beautiful. How do we find the first, the second, and the third numbers of the sequence? How do we find it? Pretty simple. We are looking for A2 and A3. Remember, A2 is the first plus the difference, right? So we have to do in our calculators 5 plus 2 over 3. Can anybody say it, please, in the chat? This is 15 over 3, 17 over 3. Right? No? Thank you, Lily. Thank you, Tefa. Beautiful. For the second one, again, take the past one, so 17 over 3, 17 over 3, and add the difference, 2 over 3. Right? So we can do this immediately. This is 19 over 3. 19 over 3. Okay, we have our first two terms, A1, A2, and A3. Okay, question B. Write down an expression. All right, but what is that? Remember, every single time you find the word expression, every single time you find the word expression, what the question is asking is for a formula. So in there, it says, write down a formula for the nth term. Nth term means this one, A sub n. That is the nth term. The number in the position n. The nth term. En español se conoce como el número en la posición enésima. Nth term o enésima posición. ¿Listo? Inglés y español, ¿está bien? What is that? What is the nth term? Means the formula for A sub n. That is what it means, a formula. And to do that, we are going to use our expression, the ones that we just deduced, or this one in the book. Here, it is right here. Look, you're looking at the screen. It is right there. To do this one, we just use that one. So it says that the A sub n is equal to the first one, so 5, right? The first position, that is what it says there, the first position, so 5, right? Plus n minus 1 times the difference, 2 over 3. From here, all we do is do the operations. All we do is the operations, right? N minus 1, you can distribute this. You can do the distributive property there, right? So again, A sub n equals 5 plus, if you multiply this is 2/3 of n minus 2/3, right? Distributive property, guys. You can do that, right? From here, these two numbers, 5 and negative 2/3, are like terms. So you can do that operation. If you don't know how to do those operations in a piece of paper, you do it in a calculator. You take out the calculator and say 5 minus 2 over 3. Here. A sub n equals, this is over 3, 15 over 3. So 13 over 3 plus 2 over 3 n. This is our formula, our expression for the nth term. Okay? Let's do a little review. Nth term means the nth position. To find the nth position, just replace in the values of the formula. Here was the first position, so 5. N minus 1 times D. So 2 over 3, because that is our d. From there, do algebra. Distributive property, 2 over 3 times n, negative 2/3. And then 5 and negative 2/3. Those are like terms, so you can add, in this case, subtract these two, right? So you do that. 5 minus 2/3 is 13 over 3. And there you go. That's it. Let's go for the third one. Determine whether or not 49 over 3 is a term of a sequence. Is it a term of the sequence or not? How will we do it? How can we do it, guys? 49 over 3. Man, I know the first is 5. The second is 17 over 3. The third is 19 over 3. So I could continue doing that to find if 49 over 3 is a sequence, is a number of the sequence or not. I could just continue doing. I could just continue with 8 over 4 and 8 over 5, 8 over 6. I'm sorry, 8 over, no. 8, 4, 8, 5, 8, 6, 8, 7, 8, 8, 8, 9, 8, 10, and all of that. I can just find all of the numbers and see if 49 over 3 appears in that list, right? Or we can use the formula. We can't use the formula. All we have to do is replace n with numbers from 1 to whatever. If this addition, if this formula gives 49 over 3, then we are good. Because 49 over 3 is a term of the expression, of the sequence, right? Remember, this formula gives us every single term of the sequence. So if this result is 49 over 3, congratulations. That means 49 over 3 is a term of the sequence. So you just grab this in the calculator and change n by 1, 2, 3, 4, 5, and on and on and on. Eventually, you're going to get close to 49 over 3. If you pass it, but you didn't get it, then 49 over 3 is not a number. But if you reach it exactly, then 49 over 3 is a number of the sequence. Did anybody do it or not? Lily did it? Beautiful, Lily. Is it a number of the sequence or not? It is, right? It is. Oh, man, a lot of you did it. Okay, cool, thank you. Secretico, secretico, secretico. No le digan a nadie. There is another way. Instead of having to use the formula and replace the values of n, we can use it backwards. Look, we want an to be 49 over 3. That is what we want. So let's just replace this in the formula and isolate n. That will give us the position where 49 over 3 appears. If n is 20, for example, that means the 20th number is 49 over 3. Cool. If n give us a decimal number, I don't know, 20.1, whatever decimal, that means this is not a number of the sequence because it's between two numbers. We can isolate this, all right? Let me isolate it for you right here. To isolate this, I'm going to do 49 over 3 equals 13 over 3 plus 2 over 3 n. And I want to isolate n. That is what I want. I want to isolate n, right? So let's just pass everything to the other side. Here, this 13 over 3 is adding, so 49 over 3 minus 13 over 3. I just pass it to subtract. This would be 2 over 3 n. Sure, I am using fractionaries. If you don't like it, pass these to decimals. Pass those to decimals. You're good to go then. From here, do that subtraction, right? 49 minus 13, this will be 36 over 3. And this is 2 over 3 times n, right? Beautiful. But look at that. This can be simplified. 36 over 3 can be simplified, right? How much is that? That is 12. This is 12, right? This is 12. So 12 equals 2 over 3. n. That is 12. To isolate the n, 36 over 3, 12. Just pass the 3 to multiply and pass the 2 to divide. So we have 12 times 3 over 2. This is n. Again, the 3 is dividing, I pass it to multiply. The 2 was multiplying, so I pass it to divide. Put this inside a calculator, and you're going to get that this is 18. Right? 18? Thank you, Paul. In other words, the number 49 over 3 appears in our sequence in the position 18. Remember, n, the little n in here, means the position of the sequence. And n is 18. So 49 over 3 is the number in the 18th position. If this number, if n, was a decimal, for example, 18.5, that means our number 49 over 3 appears between 18 and 19, in the middle. 18 and 19, right there in the middle. That means this is not a number of the sequence. This is not what is happening here. The number is complete. 18, right? Beautiful. Beautiful. So yes, this number belongs to the sequence. Mari says, Profe, Dani dice que no puede entrar al meet. Okay, thank you, Mari. It is 10 already. It is 10 o'clock. Guys, we need to go, right? We need to go. We're going to finish the class here. Let me stop the recording.